Hey there, guys. Sorry about that. My laptop that I was using got a blue screen of death, which I haven't gotten one. I haven't gotten that on this other laptop. So I'm back. How much did you guys see? I was describing SNMP, right? Were you guys getting a good idea of what SNMP was and MRTG was? I'm booting up the other computer, so I'll probably switch over to the other computer. Can you guys hear me okay? Okay, so go Google make sure you understand what SNMP. It's a protocol. It's an application layer protocol, even though it's looking at layer 3 metrics. It's looking at layer 3 information, but it's happening in an application. Understand what managed switches are and managed devices. They are actually running additional programs for purposes of monitoring what's going on and also controlling what's going on. Some devices only allow you to monitor what's going on. Others allow you to actually issue commands to them, typically not through SNMP. SNMP is typically just a one-way style of protocol. You log into the device with a username and password, which is stored, and it's called a secret at that point, just like with VPN. It's stored in a database somewhere, and you log into that device, and then you download code from it. You don't typically upload code or application data. Okay, my other laptop is back up, so let me see. I'd rather, like I said, continue there, but let me go ahead and talk while I'm here on this one, and I'll try to sew these videos together. I'm trying to remember what's next in the notes. Actually, if you guys just bear with me, this other one's coming back up. I don't think I have chapter 12 downloaded on this one yet. I'll go look in downloads here. Oh, there's a lot of stuff in there. Yeah, there's an old chapter 12. All right, we'll bring that one up. Okay, so going back to where we were, talking about SNMP, data is stored in what's called a management information base, or a MIB, a database basically. So typically the way it's used is the data, there's actually three players involved with SNMP. The device itself, which is represented by each of these little switch icons here. Then there is at least one server somewhere logging into the device and collecting the data out of it, like a web server, for example, or a centralized server. And then you, as a workstation, you log into that server. You don't typically log into the device itself directly. The only time you log into the managed switch is if you need to change something or you want to look at real-time data. Most of us network managers, we're logging into a server, or what we call a watchdog server, or a watchdog machine that's watching one or more managed devices on the internet for us, or on the network for us, gathering all that information, storing all the data in a text file or in a data file, so that on demand we can log into that server and view the historical data. The reason we don't typically log directly into this switch is because switches don't usually have hard drives in them. They have memory in them, and they have some non-volatile RAM. But typically, when you turn a switch off, any historical data or log information that it was keeping, excuse me, is lost because it's just in RAM. So typically, like I said, there are 3 players, one being the device itself, one being an intermediate server to capture all of the real-time data and put times and date stamps on it. Then you speak from your workstation to the server and not to the device itself. So this is somewhat misleading, the way that this is actually not the best graphic to show you for that function, or that behavior, but understand that that's how that works. I'll just go ahead and continue on this computer, if that's all right. Let me switch some things around. I run the risk of this computer crashing, but that's okay. If it crashes, I'll switch over to the other one. We'll see what happens. That way I don't have to be too disruptive. Okay, here's another concept in terms of network management. The managerial issue we're trying to solve is balancing our traffic out. If we are getting, for example, too many requests on the internet to speak to our website, uh.edu, for example, and we've maxed out the web server as much as we can. We've put as much memory in it as we could. We've added as many physical network interface cards as we could to get more roads into that server. If there's nothing else that we can do to that server, or in this example, let's pretend these switches are not here for a minute. So if this is the internet and this was our one web server in the world for uh.edu, all of the traffic is coming from the internet hitting that server. That server gets too busy and we've maxed it out, we can add a second or third or fourth, or in this example, this is called a server farm, or sometimes we also call it a server cluster. We call it a cluster if all of those servers look identical to each other and operate physically identically. One could die and the other one could take over, kind of like clones. A server farm might be each of these servers are operating independently, and some might be running some other different apps, but they are also running the www.uh.edu application and all have access to the same data. So what some organizations do with large usage of their servers internally, their web servers, for example, is they put a load balancer in, a high-speed load balancer. So this thing has an IP address, a public-facing IP address. Sometimes that's also a firewall. Some firewalls have load balancing capability built in. Sometimes there's not a switch here. This is a combined single device a lot of times. I get at my office, it's a combined single device. The internet hits my load balancing switch here. The switch sends a request that goes to server 1, for example. It says, hey, I've got a web request here from Jake in Houston. Can you take that request? And server 1 might respond back, no, I'm too busy right now. So the load balancer will send it to server 2, 3, 4 until it finds one that's not busy. The way this works, and the reason this can work, is because of network address translation. Not specifically because of it, but actually, let me take that back, because there are external and internal IPs. All of these servers have different IP addresses, but they all look like, to the real world, like one server, uh.edu. Or sometimes it does look like different servers to you. If you go to chase.com, for example, and you click to log in, you'll notice that your URL on the address bar actually changes, and you're at chase21.server3.something.chase.com. It's literally changing you to the DNS name of the server that you happen to be logging into at the time. And you may be logging into one server today and a different server tomorrow. That's one way that they do it. I like to do it, and I prefer to do it how U of H does it, where when you hit uh.edu, or Amazon.com, for example, or eBay.com. It looks to you in the outside world like you're talking to eBay.com. It looks to you and it looks to your computer out here on the internet that you're talking to one public IP address in the world. eBay.com is always one specific IP address, but not really. It's actually 10 or 15 or 20 other addresses, which might be private, or but the point is they're internal. It's called load balancing. This is kind of similar to a multi-tiered network. Remember how we were talking about n-tiered technology or 3-tiered technology between clients and servers? This is that case. This is an n-tiered technology. We can do a one-to-many relationship, or actually this is a many-to-many relationship. The internet is many. These servers are many. But as far as you, the user on one computer out here on the internet is concerned, it looks like it's a one-to-one relationship. So we use load balancing to create a one-to-one relationship for you, the outside user, to talk to server data, to offload the traffic, offload the processing requirements from one device. Now, in order for this to really work, all these devices, all these servers need to have either exact copies of all the same data, or what you'll find most of the time, guys, is that these servers that are running the web pages and the FTP sites and the email services, they're actually all talking to the same network attached storage, which is might look like one of these servers, but it just has a bunch of hard drives in it. And that's all the job that it does. In other words, there's a fourth tier back here. There's a multi-tiered situation. You've got the internet, the load balancers, the internal switches, which aren't really part of that's not really part of the tiering in this case, because that's at layer 2 or layer 3. It's layer 5 that the tiering is happening. So you hit these application servers, and then they actually go look for the data somewhere else behind this server farm. Okay. What else can we do to manage network traffic? That's what we're talking about right now. Network management, not necessarily you as a network manager managing the day-to-day operations, but what can we do to manage traffic when it becomes a problem? How do we manage traffic on streets when they become a problem? We have intelligent, not everywhere, but in most parts of Houston, when you're driving around, we have intelligent street lights. You drive over a sensor that's in the street, in the underground, and it registers a certain amount of metal in your car. So it knows, hey, there's a car here. I'm going to count the number of cars that are in this lane that need to turn. And if there are no other cars in any of the other lanes in any of the opposing directions, I'll go ahead and change his light green and make it a priority. Rather than, and I know that this is frustrating, I know some of you have had this situation before where you are in a small town and there's a traffic light and it's 3 in the afternoon on a Saturday, or maybe it's a slow day, and you're sitting at a red light and the light's green in the other direction, and it's just green, 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 like 30 seconds pass, it's still green, there's no traffic coming. You're like, this is stupid. It slows you down. So automating traffic speeds things up, and we try to do that with managed devices where they can tell when there's traffic there or not traffic somewhere else, and give prioritization to traffic when it needs to go from point A to point B. Traffic shaping, either by protocol or application. Typically we do it by port number. It's typically how we do it. We can either block or limit traffic, or we can also do it with this quality of service flag. So we can do it by port numbers. We can say port 80 traffic, we'll give that the lowest priority. That's web traffic. It can handle low priority. Streaming video traffic, that needs high priority based on a port number. What did we say Zoom was using? Port 2081 or whatever it was the other day. We figured it out by using Wireshark. So we could put in our switches rules that says, if you get any traffic using this particular port that Zoom uses, treat that with the highest priority. Let them through first. Hold the port 80 stuff, hold the port 21 stuff. that can hold on for a little while. Or if it's using this quality of service flag, which is inside, there's a place for quality of service in both the IP packet as well as the Ethernet frame. It's called traffic shaping or traffic limiting. Traffic shaping literally means we're trying to cut off the peaks and the valleys, usually cut off the peaks, not the valleys, but the peaks. So we can either do it by protocol or application, or we can limit it by IP address. And we can say, well, we only want to allow up to, in this example, we've got a total bandwidth of 20 megabits per second. Maybe there's a particular application, like let's say the video application, and it is just maxing out our bandwidth. So nothing else can happen. If it's pegged at 20 megabits and the video traffic's going through and its quality of service is flagged as high and important, you won't get any other traffic moving through. Email will crawl to a halt. Downloading files will crawl to a halt. So we can tell our switches based on source and destination IP address. In other words, if traffic's coming in and it's trying to talk to our streaming servers, which are streaming video, only allow through up to 10 megabits per second. That way there's another 10 megabits per second of bandwidth left for any other traffic. So that's called traffic limiting or traffic shaping. We do that all the time on networks to try to better control traffic. You can think about this not physically, but think about it logically as multiple lanes on a freeway or multiple lanes on a street in downtown Houston during certain times of the day. And I know most all of you have been downtown at one time or the other. Is that correct in Houston? During certain times of the day, the two rightmost lanes on the one-way streets in downtown are intended for buses only. They're the bus diamond lanes. And if you're in them, you can potentially get in trouble if you're in them all the time. A police officer may pull you over. You're not supposed to be in them unless you are specifically turning at the next intersection or whatever. It's trying to limit or shape the traffic. That rule is trying to shape the traffic and say you can't be over there right now, even though there is the bandwidth there, because we need that area for buses so they can get through downtown. Okay. Content caching. And I've mentioned this before in terms of speeding up network traffic. Content caching happens in a couple different places. And when you're doing the Wireshark assignment or the Wireshark extra credit, that's one of the things that you're discovering by using Wireshark is that sometimes content is cached and sometimes it's not. So one of the experiments is go to a website that you're very familiar with, that you go to all the time, like uh.edu. Load it up while Wireshark is running. You probably won't see very much at all in terms of traffic coming down into your computer that's being visible on Wireshark, because most of that traffic, or excuse me, most of that content is already stored on the local hard drive of your workstation. So you won't see it. Only when you go to press F5 or the refresh button, or when you go to a website that you've never been to before. You know, think of some of very obscure website, chowderheads.com or, whatever. Something that, Canadiansforjesus.com or something that you normally wouldn't go to, and you'll get no caching going on. Now, your local hard drive is not the only place that occurs. There are actually networks. Anybody ever heard of Akamai? They're typically associated with gaming. Anybody in here play Fortnite or any of these other network games? So there are gaming servers that are all essentially displaying the same game, the same Fortnite session all over the world. But because the world is kind of big and there's lag between continents, between Asia and the United States, for example, the same data is stored on multiple servers. So if you're here in Singapore, which is interesting, I just sent a package to Singapore today. Go into Foxconn. making some more iPhones, I guess. So here there might be some users in Singapore playing Foxconn, playing Fortnite, and you might be here, and that says California. That's probably San Francisco, I'd say, playing Fortnite too. You've got an identical copy of all of the maps and all of the layouts and the commands and everything on a local server. So when you're logging into a particular server, you're logging into the San Francisco version. The kid in Singapore that's playing against you, that's shooting your butt up, excuse me, that didn't sound right, that's beating you. I get beat a lot by a bunch of 13-year-old kids. Apparently when you get older, you get a little slower with the reactions. So they're seeing a copy. Now, the only data that's actually going back and forth between these two sites is coordinate data. Very little bit of data, like where you happen to be standing at the time. But all the bits that make up your avatar and all of the data that makes up the backgrounds and the maps and everything else that's showing up in the games is stored on a local server copy within your geographic area. Most organizations don't have their own content delivery networks to do this, so they hire companies like Akamai. And IBM actually does this for other companies as well. They make copies of databases and host those databases. They call them mirrors, database mirrors. They host mirrors all over the world. If you want to download applications, if you want to download a version of Linux, for example, like you want to download Red Hat or Debian or Kali Linux, you want to become a hacker. So you say, I want to go download Kali Linux. When you click on, or you go download CentOS. My favorite is CentOS. You go to centos.org, you click the download button. Based on your IP address, you are directed to, and sometimes you don't even know this, you're directed to the server that you're physically closest to, which for CentOS is usually going to be University of Texas or Texas A&M, because they are part of this hosting mirror network that hosts Linux. University of Houston doesn't host any. We used to host, or I personally used to host at U of H, some IRC servers, but those all got shut down. So we don't use those anymore. Content delivery networks. Again, this is solving the problem of, reducing network demand. We talked about that in the last couple of chapters ago. How do we reduce network demand? One way is to move a lot of that static data closer to the users, physically closer to the users. Okay. Let's see how we doing. Oh, I've got something in chat here. Let's see who's asking me a question. What is CentOS? It's actually spelled this way. CentOS. That's a good question, what CentOS is. So CentOS is a distribution of Linux, the Linux operating system, which is the most common operating system on the planet. Mac OS is based on something that looks like Linux called BSOD'ed. All of your TV sets, all of your Android phones, all of your smart devices, your smart clocks and your smart bulbs and your smart thermostats, anybody have a Ring doorbell? They're all based on Linux. And what CentOS is, and there's also Debian, and there's Ubuntu. Anybody watch Big Bang Theory? Sheldon on Big Bang Theory, he's a big Linux guy. He says Ubuntu is his favorite distribution. Linux is a free open source OS that anybody can download and create applications for. These companies, not Linux, but CentOS, Debian, Ubuntu, there's a few others. There's Red Hat, which is probably the biggest one now. They put out distributions of Linux with prepackaged applications. It's kind of like going to a third party to buy Windows, not to Microsoft. You go to a third party to buy Windows and they've preloaded a bunch of other applications in with it to tailor it to a certain user or a certain industry. I highly recommend checking out any of these distributions. Red Hat, by the way, was bought by IBM about 2 years ago to the tune of $34 billion to buy free software. Linux is free. You can download it for free. Why would IBM pay $34 billion for this company? Because the way these companies make their money is subscriptions. You want to install Red Hat, you want some hand holding, you want to be able to call, somebody on a help desk and say, okay, how do I get networking working? Pay me $10 a month and I'll tell you and I'll teach you how. That's how these companies make money. So they make $10 a month off of 50 million people in the world. Anyway, that's what CentOS is, if you're curious. If you're really, really curious and you're still in school, next semester, sign up for my 4397 class called Open Systems. I teach Linux and CentOS and Debian and Ubuntu and how to install what's called the LAMP stack. I am a contributor to the original Linux kernel. Way back when it was version 0.59 is when I came on board, it was only a couple of months old at the time. Let's talk about configuration management here. Configuration management is adding and deleting user accounts. Now, this used to be what took up 90% of our jobs, adding and deleting user accounts. In fact, at U of H, they were really bad about deleting user accounts. They were fairly good at adding them. An automated process was put in place finally to add accounts because, of course, we add several thousand new students every semester, literally. But we also delete or should be deleting several thousand students every semester as they graduate. Or as professors retire, or as people quit and move away. After I got my first degree at U of H in 1985 or 6, I took a few years off to do other stuff. When I came back in 1988, my jake@uh.edu account was still alive. In fact, during that hiatus, when I wasn't there, when I went into the Air Force, I was still able to log into my U of H account for 2 years after I graduated. That is a big, huge security hole. It's a bad thing. Companies used to be really bad at that. Now we've gotten much, much better at it. And it's on an automated process because that's one of the hugest, not only is this one of the most time-consuming things, and nowadays it's all automated. You want to add in your own account? You want to get a Google account or a Gmail account? It's all automated. You just go to a website and answer a few questions. It does it for you. There's not some guy setting it up for you. You need to change your password? That's all automated too. We do that at U of H. It got to the point where 90% of the calls to the help desk, talk about the help desk in a minute, was, I forgot my password. Can you change it for me? That's what drove that automation. Updating software on client computers. This used to be a big ass headache too. Every semester, we used to do this for the labs. There was a lady that used to work here. She ran the RICS department, Elaine Brewer, and she came to me back in 1996 or so, or 98, and said, every semester, we have to go through all of the labs at Melcher Hall, and presumably everybody needed to do this all over the university, and reset the lab computers. Because back then, students were installing their own code, messing with the backgrounds, changing things around, changing stuff up, or rendering the lab machine unusable for whatever reason, either intentionally or on purpose. That's the same thing, accidentally or on purpose. And so what they were having to do is they were walking around with a CD basically and reinstalling Windows or resetting it every semester. Well, there was at the time, 200-300 lab computers. There's probably still that many, although we don't really supply lab computers as much as we used to. That's because everybody's got their own computer. So what we were doing, what we tried to figure out is how can we automate that? So I helped the RICS department put an automated process in place to, after every semester at a certain date, those lab computers would reboot and uh, automatically boot up a network version of Windows and erase everything on the old lab computer and reinstall Windows. And it was automated, so nobody had to do that because that took a lot of time. Software these days pretty much updates itself, although this can get you in a lot of trouble. Got me into some trouble the other day. About 2 weeks ago, a manufacturer pushed out an update or a change to the firmware of a router which had bugs in it. All of my clients that were using this particular brand of router suddenly are calling me on Monday morning. Hey, I can't get on the internet. I can't use my phones, blah, 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 blah. It's unfortunately the update that they put out had bugs in it and it didn't work and they didn't test it well enough. So automation has pros and cons. You need to make sure that you fully tested and fully vetted these automated procedures to make sure that they work. But the time savings is huge. Updating software, a lot of times I, as a network manager, would have to say, okay, everybody's going to go home early on Friday because it's going to take me and Jose here like all weekend, all night to update the 2,000 workstations at this company so that we can go from Windows 7 to Windows 10, for example. Or maybe not even that drastic. Maybe we're just going to a new application. We had to shut down the databases, update everything, run scripts on the databases to bring them into the new version and then turn everything back on. That is a huge time waster, but that's part of configuration management. Documenting the configuration. This is a thing, like I've said before, 5 or 6 or 10 or a dozen times. I can't tell you guys enough. Documenting the configurations is critical. Unless you just want to spend a lot of time going down roads that you've already been down, but you can't remember, did I go down this road or not? Did I solve this problem or not? Did I have this problem or not already? Network diagrams, keeping track of where all the network components are, not just where they are, but what they are. What versions of firmware they're running, who has access to them. Maintaining the software, who has access to the software, and then the user and the application profiles. There's 2 different kinds of profiles here. There's user profiles, that's the username and password. Then there's the profiles of the applications themselves, what the applications do, what they log into, when they're supposed to run and when they're supposed to update. Then you have network profiles, which is more like a user profile. What resources on a network do certain users have access to and when? But you should be spending, these days, you should be spending much less time doing this. Very little time doing this. This desktop management item, by the way, we have a specific group now that does that, which is more or less divorced from the network manager or the MIS manager. That is a function that we hand off to a team called the help desk or the failure control function. I'll talk about that in a minute, because this is one of the hardest things to do because it's dealing with people. So you should be spending 50% of your time on documenting, maintaining the documents, rereading the documents, updating the documents, creating documents that don't exist. That's why I'm really hoping everybody, whether you need the extra credit assignment or not, that you will do Windows updates turned off. Okay, whatever. That's probably for a reason. Yeah, sometimes I turn updates off. Like if it's a critical server and I don't want it to automatically reboot, I'm going to turn Windows updates off and I'm going to schedule it when I want it to happen. Microsoft gets a little overzealous on, oh, we're going to update things for you whether we think you need it or not. That looks a little bit like your map, doesn't it, Franklin? That's an example of a network diagram and configuration management. We try to, when we draw these things, by the way, let me just describe this drawing. This is kind of similar to what we have in the EI lab. You guys, unfortunately, most of you have not been in the EI lab, you couldn't see it. But you've been in other, hopefully you've been, or you've seen movies or whatever, where you've seen server rooms that have database servers and web servers in them. So this might be a computer room that has a bunch of racks of servers in it. This is a representation of the connecting device that connects them all together, or this might be the network attached storage. We use different types of lines. This is what I'm not seeing, by the way, in draw.io. So if you are going to do the extra credit draw.io, make sure you use different colored or different styles of lines to indicate different network types, different network speeds. For example, if you decide, because you're making a lot of this up conceptually in your head, but if you decide, I want to connect building A to building B, or floor 1 to floor 3 with a high-speed network of fiber, you should maybe make that line yellow, or yellow with a black outline, or red, or some different color, and then make their standard gigabit Ethernet lines green. And then if you have lines that are feeding telephones, voice over IP telephones, make those blue or orange, or make them some other color. You'll notice in this example document drawing here, also we've conceptually drawn boxes around groupings. We've grouped the hardware together, so it should be fairly easy to tell when I look at this drawing. Although this is not physically how the building's laid out, it conceptually tells me, oh, these two switches are on the 4th floor, and here's their IP addresses, and here's the port numbers. And in draw.io, you have the ability to put basically hypertext on that switch. So you could click on it, and it would open up another document, a text document or an HTML web page that shows you all of the details of that particular item, that particular object. I like it when people do that. I try to do that all the time. I'd love to be able to hypertext click on one of these servers, and it opens up a window. It tells me everything about that server, what applications are running on it. And even if it's static data, it doesn't have to be dynamic. It's great if it's dynamic. If I can click on that and it opens up the actual URL, and you can do this in draw.io, and this is what I do. For my Proxmox servers, for example, I literally put the URL of the login dashboard for that server in the object. So when I click on it, it fires up my web browser. It doesn't necessarily log into it because that would be kind of a security risk. So I still have to log into it, but I didn't have to retype in all of that stuff. And then it'll take me right to the dashboard that I wanted to see, gives me critical information. Huge time saver. Okay, so I can't stress how important document management is. Performance management. Many organizations use a dedicated network operations center called a NOC to monitor networks using network management software. This is an example of one of what I used to use this furniture for my NOCs, where I had multiple screens and a nice Polycom. That's my old Polycom cell phone from 1,000,000 years ago. This is an old picture. Now that says that's there. This is one of mine. This is not theirs. I put my picture in because their picture was no good. I think that's mine. Looks just like mine. Anyway, this is a network operations center. We're monitoring several networks. You'll notice that not only am I monitoring, I have some MRTG going here where you can monitor network servers. I've got some drawings up here so I can have a graphical representation immediately in my head or my eyes of what the networks look like, network diagramming or layout looks like. I've also got cameras. This is real common in a NOC, to have video cameras in high traffic areas, not necessarily where people are, but where network assets are. Monitoring the network assets to see if there are people using them, or if they're on fire, or if there's something happening to them, or they're being stolen or being carried out the door. Network operations center. We don't typically deal with end users. The guy that sits here is not an end user friendly kind of guy. He's a very analytical kind of guy. Many of these people that do this job, which you're looking for red flags, that's what they're looking for. managing by exception. They have Asperger's and are not socially. I'm not saying they all are. I'm just saying that tends to lend itself well. People that pay attention to minute things and little things that bother you. It's good to have that kind of person in that job. The failure control function is performed by another group, which is not the NOC, called the help desk. The help desk has a few different functions, but primarily they are there to be reactive, not proactive. The Network Operations Center, hopefully, is proactive. We notice trends. We notice on graphs, things are going towards 100%, but not there yet. Things are crawling up slowly. Oh, well, I got some hard drives about to fill up. I better go do something there before it fills up and crashes. Whereas help desk people, or a help desk, maybe not, it might not be a person. A lot of times it's a person. Sometimes it's a program that acts like a person. Has anybody ever gone to a website where you were considering buying something and then it'll pop up, comes up, hey, my name is Sally, may I help you? And you can ask it a few questions. A lot of times those are programs. Those are AI programs. Those are artificial intelligence programs, not to be confused with machine learning programs, that are trying to answer the most common questions that you might have. How much does this cost? What are your hours of operation? How long does it take to ship something? But a lot of the help desk is people. First line of defense, first thing that happens, and I know a lot of you have called help desks before. You've either called the power company, your cellular provider, your internet provider, your credit card company. You've called U of H because you had an overdue bill, whatever it was. First thing they ask you is, hi, is this a new issue or do you have an existing ticket number or an existing issue? That's because everybody uses trouble tickets. The reason we use trouble tickets is so that we can track problems, and it makes for a faster experience, because a lot of these help desks these days are outsourced. Everybody knows what outsourcing is, right? Is that a good thing or a bad thing? Some people say, oh, outsourcing is a dirty word, but it depends on what kind of business you're in. Outsourcing is potentially a very good thing. There are a lot of bureaus, help desk bureaus, that are in other countries, such as India or the Philippines, or we're seeing more in Indonesia now, where they speak well enough English, or they speak well enough of the language that they're trying to provide the services for. That's why we're seeing a lot in the Philippines, by the way. And yes, that's correct. That's because the FTE, the full-time equivalent per hour charge that I have to pay for an employee in the Philippines versus United States is 50% or less. It used to be that case in India. Not so much. India is actually getting more expensive because they are getting better at what they do, and demand versus supply, that changes. So that's what drives that. Bangalore, yeah, there's help centers in Bangalore as well. Amazon has centers in all over the world, not just Bangalore. So they do that because it's cheaper, but not always. It's not just because it's cheaper. It's because there's a huge number of people there that need jobs. That's why there would probably be more in China, except the Chinese language is so different than many other languages, very different than Latin-based languages or Germanic-based languages, that there would still be an accent barrier a lot of times. I'm trying to be not politically incorrect here, but that's the easiest way to explain that. So you will find that a lot of the help desks that cater to the West, cater to the United States and North America, at least, are located in countries where the language is, the pronunciation, the phonemes are close enough to English, or maybe that English is a primary language, like India, like the Philippines. Everybody in the Philippines speaks English and presumably Tagalog or whatever else they speak, but they have pretty easy to understand accents for most people here. But we are using the trouble ticket system for several things. One, so that when you call back, it's likely you're never going to talk to the same guy again, for one. So you don't want to have to repeat your same problem over and over and over again, or you've gotten more information on a problem. They can look up what your problem was in the future, in the past, and hopefully give you a much quicker answer. Maybe you're a problem user and you have the same problem over and over because you're just not a very good user, or you forget stuff. And they can give you a tailored experience. But we also do it so that we can track problems and we can pay attention to the problems that occur the most. And that we can derive statistics from that. So for example, if I'm a network manager, because network managers do this also, we look at reports weekly or possibly just monthly of the failure control function. And we look at like the top 5 most common problems. And in order to do that, we have to be able to quantify the problems. Most help desk software has 10 of the most common problems: forgot password, user error, things like that. And those are associated with numbers 1 through 10. And so I can take a look at those reports and see, well, is the forgotten password issue causing more calls to the help desk than anything else? If it is, then maybe that's where I want to pay attention to figure out how I can automate that process. And that's why all this password forgetting stuff, it's all automated. Very few websites, very few applications, very few companies that you do business with still require you to call them to change the password. They've all automated that. And that's because that's the most common thing that happens. And that's the most common reason for people to call into a help desk. And that's because maybe you're using an application once every 6 months or once a year. You're logging into United Airlines to book a flight once a year and you don't remember what your password was, or it's been changed automatically. So here's an example of some ticket reports you might look at. We try to assign priorities. Now, sometimes in the failure control function, keep this in mind, the help desk is there to deal with problems that occur 80% of the time, the 80% most common problems. There are going to be some problems that occur 20% of the time that are unusual, that the help desk can't answer, but they don't happen very often. Those kind of problems are escalated. We call the term escalation, and I know some of you have experienced this before. The help desk person will ask you a series of very simple questions to start with. Well, is there power to your computer? Yes. Have you rebooted your computer? Yes or no? And they'll answer these questions to try to narrow down what the problem is, trying to fix it for you by simply going through a list of questions to ask, a decision tree. Most help desk people are not technical. A lot of times they don't even know what they're reading. They're just reading what they're told to read. Please press this, open this screen, click here, type in XYZ, W123, click here, press OK, press submit 2 times, enter, and it's done. They don't have any idea what they're doing. They're just reading a script. They're not technical people. They're social people. They're there to make you feel better. But occasionally you have a problem that they can't solve, so they escalate that to upper level management, which sometimes is the network operations center. Sometimes what happens is you get what's called an alarm storm, or a help desk storm, where many people are calling in all at one time, all with the same problem. That gets escalated almost immediately back to the NOC, because what that usually means is that you've got a system-wide problem. Your website has gone down, for example. People go, hey, I'm trying to buy stuff on your website, and every time I go to put in my credit card number, it says, sorry, please try again. If Amazon.com or a Home Depot or maybe not somebody as big as Amazon, but a retail site gets 1,000 calls in the past 5 minutes saying, hey, we can't buy stuff on your website, that usually automatically gets escalated. So that's a reason why we use CRMs and trouble ticket systems. Salesforce.com, by the way, you can go check out salesforce.com. Or there are several of them. That's probably the most popular one, used by Xfinity. And that's what they do. And I think Xfinity has a pretty good customer service function compared to AT&T, who uses something that they developed in-house over the years. It's not very good, in my opinion. I don't know if that's because AT&T's not very, they've gotten better lately. I actually had to deal with AT&T today, and they were a lot nicer than they've usually been. They didn't make me feel like an idiot. But I can just tell, because I've called so many help desks, I can tell what software they're using based on the questions they're asking me and in what order. So I know Xfinity's using Salesforce, and I'll ask the customer, or I'll tell the technician sometimes when I call and say, go down to field 3 on Salesforce and type in this number. And they're like, how did you know that? I'm trying to freak them out. Say, well, I can tell you're wearing khakis, and try to scare them. And you've got brown hair, and like, oh my God, are you looking at me? No, I'm just going by statistics. Statistically, help desk people have brown hair and wear khakis, just like the State Farm guys. So anyway, everybody asks me if I'm wearing khakis because I'm Jake. It's, hey, Jake from State Farm. Here's a couple of, my other laptop rebooted again. It's a good thing I'm not using it now. Performance management. Another part of performance management is some statistics. Some of these are not that common in the industry, but this term, you do need to know what that is. MTBF. Are we doing on time? We're okay on time. MTBF, mean time between failure. First of all, let's take a look at some of these terms. Availability. And there is an availability term, by the way, called the 5 nines. Has anybody ever heard of the 5 nines? And yes, there's a big hacker group called the 5 nines. By the way, they're international espionage. But the 5 nines is talking about and referring to an availability of 99.999% uptime or availability. Where's my percent? There it is. 5 nines. Most service organizations strive to offer you the 5 nines in terms of service level availability through something that's called a service level agreement, by the way, an SLA. I don't think that's in the book, or if it is, it's not mentioned very many times, but SLA, service level agreement, those are contracts that are negotiated with outsourced companies or companies that provide your failure control function and your network management function. A lot of organizations don't do their own network management. They hire outside firms. So if you go to work for a network management company, you may be working for Exxon or Ernst & Young or Xfinity even, but you are working for an outsourced company that provides that function to them. You might be living in a Comcast building or an HP building, but you're working for another company. Just keep in mind that most of the network management function these days of large organizations and almost all small organizations is outsourced. Excuse me, not just the help desk. The availability or uptime, the 5 nines, is measured in terms of a year. We strive to offer that your network or your application will be available to your users 99.999% of the time. That translates to about 30 minutes of downtime per year or less. Actually, it's less than that. It's like 5 minutes of downtime. You pay for that. If you want 7 nines, 99.99999% of the time, you pay more money because the network management company is providing redundancy and extra things they have to pay for to make sure that your network doesn't go down. Akamai has different tiers that you can pay them, and they ask you, how reliable do you want your network to be? Do you want eBay reliability where we don't go down? Or do you want Comcast reliability where, you know, we go down occasionally and we're up within a few hours? Unfortunately, Comcast doesn't have really good reliability. Or, you know, as bad reliability that I've noticed, Comcast is not a good example because they have different levels. For end users, they don't have any reliability other than we'll give you internet hopefully 30 days out of the month, but one of those days it might be down for several hours. The banking system, Chase.com, for example, I have my bank accounts at Chase. Several times over the past month, I've gone to Chase.com, not at weird times of the, not at 3 in the morning on a Sunday, but like normal time of day. We're experiencing difficulty right now. Try back in a few minutes. Has anybody else noticed that with Chase or maybe Bank of America? And I think that's just because their server loads are getting so high. All the banks are closed right now. They don't have the employees to man the bank location. So all the Chase branches are closed. Yeah, Navy Federal. I'm also a Navy Federal member. Thank God I don't ever have to go there, but I did have to go there the other day, Franklin, and I tried to walk in the door and it said, no, you got to make a, you have to make, unless you're an admiral, you know, you have to make an appointment. So I had to go make an appointment to go talk to him about my my truck loan, which I have through them.
Oh, that's crazy.
What's that?
No, I said that's crazy that they made you schedule an appointment.
Yeah, I had to schedule an appointment, and when I did, it was like we have some availability like next Thursday at 3. It was like a week later. So these are terms. These terms down here, by the way, I don't really personally see these terms that often in the industry, but all of these elements, what's important from this graphic here is that all of these elements, the mean time to repair, the average time to repair an issue is comprised of these 3 elements, the mean time to diagnose. Many times a problem occurs and the diagnosis is instantaneous. Well, the power's out. Well, that's pretty easy to diagnose. If the grid power is out, not much you can do to get the grid power back on, but you can put something in place to redundify the grid power, like a backup generator. But sometimes you have a problem and it's difficult to find what the problem, not what the problem was, but what caused the problem. Like my laptop keeps rebooting. I don't know why. It's going to take me a while to diagnose that problem. Mean time to respond is the time it takes for the service organization or the service provider to respond to the problem. Most service organizations, with respect to utilities, the internet lines that are coming to your building, have a committed response time of 4 hours or less. Mean time to fix, how long it's actually going to take to fix the problem when they get on site, if it's a site issue, equals the total mean time to repair. We measure service organizations' reliability and track records on their total mean time to repair an issue. Mean time between failure is a different measure. That is a statistical measure. It really shouldn't even be on this same slide. I didn't make these slides. Mean time between failure is a statistical number, typically in hours, that's put on hardware, such as hard drives. The next time you go buy a hard drive, or the next time you go research buying a hard drive, like you're replacing a drive in a laptop with a solid state drive, make sure you look at this under the technical specifications tabs as to what the mean time between failure is, or MTBF. Sometimes they'll call that lifetime hours. And it'll be in numbers of hours. Solid state drives have much shorter MTBFs than spinning drives. Consumer drives have many shorter hour MTBF numbers than commercial or industry drives. You can buy a 2 terabyte drive for $50. It's going to have an MTBF of about 80,000 hours. Now, will it last 80,000 hours? In my experience, no. Probably last 40,000 hours. The worst thing you can do to a hard drive, worst thing you can do to any piece of hardware is turn it off and on. Laptops get turned off and on all the time. That shortens their life. Commercial drives, their MTBFs you're going to pay for a 2 terabyte drive, you're going to pay triple, $150, $200, but it's going to have 1.8 million hours, 2 million hours between failures. In other words, presumably, in a perfect world, it could last for 20 years. Will it last for 20 years? No, probably not. But again, we're turning things off and on, and that shortens the life. Solid state drives. They're not measured actually in MTBFs. They're measured in total writes. W-R-I-T-E-S, not writes, like I've got writes because I'm a hard drive. No, I'm talking about how many times you can write data to that solid state drive. Does anybody know approximately, or does anybody have a thought about how a solid state drive works? It's magnetic, sort of. It's using a little bit different method of storing data. It's moving electrons around, and electrons can be controlled, kind of like you can control cattle in a pen, and you can move them around based on how you pass electricity through a particular chip. And one grouping of electrons in the left upper corner of a pin could mean a 1, and if they're in the lower right corner, that could mean a 0. So think of a solid state drive as a paperclip. Now, if you needed to do something like you need to reset a router, you've got that little tiny reset button on the back of your router or your gateway. They tell you bend up a paperclip and stick it in that hole, hold it in for 10 seconds, and that'll reboot or reset your switch or whatever if you got the password. And then what do you do with that paperclip? You bend it back, put it back in your paperclip drawer or whatever. You can do that a few times with that one paperclip, but what happens to a paperclip after you bend it 10 or 12 times in the same spot? It breaks. It stops being a paperclip. And it's because metal is, although some kind of metals are bendable, you can only bend them so many times. That's kind of like how a solid state drive works. You can only move those electrons around so many times before they get tired or they get lazy or they say, we're not listening to you anymore. We're just going to stay here. So when that happens to a solid state drive, it stops being able to represent your data. So if you write a lot to a solid state drive, in fact, you can download a program called a solid state destroyer or solid state stressor, and it'll stress out a solid state drive. And within a few weeks, it'll destroy it just by constantly reading and writing data to it. You can run that same program on a spinning hard drive and it'll last for years. But you can burn up a solid state drive in a year. So all that money you're spending on these 240 gig or terabyte solid state drives or these USB sticks that you think, oh, these are secure, they're 3 years max. They're not going to last longer than 3 years, especially depending on what kind they are. They have different technologies. You've got SLC, MLC, triple layer solid state drives, NAND drive, NAND drives, different types of solid state drives. And that's why the prices, by the way, guys, are so wildly different. So keep that in mind, not just MTBF, but in terms of solid state drives, which is now becoming the norm for workstations, they're measured in total number of writes. So what you'll see on there is this drive can take 20 million writes or 40 million writes on the average. And after that, we can't rely on the ability to write data. Also, by the way, a lot of times, guys, you buy a solid state drive that says it's a 120 gig solid state drive. It's really capable of carrying or holding 600 gigs or even a terabyte. But it doesn't use all of the drive at one time. It saves some of it up so that if one area gets overused, then go start using another area of the drive. It's kind of like a farmer that has 40 acres. Farmers never farm all 40 acres at one time. They farm 20 of their 40 acres, let the other 20 acres grow and replenish and recover. And then when this 20 acres, after 4 or 5 years after they've grown several crops in those 20 acres, they've taken all the nutrients out of the soil. They have to let it lay fallow for a while, let it renutriate. Basically, they use the other 20 acres. Same way with solid state drives. Here's an example of quality control charts, which might be generated from management software. You can go look at MRTG or PRTG charts. I don't place a lot of importance on these kind of charts. Excuse me. Let me see how many more slides we got here. Okay, we're almost there. Almost there, guys, and then I'll talk about exam 3. Where am I? I got lost a little bit. Where's my, oh, there he is. Okay, so you guys following along okay? Have I been advancing the slides? Have you been seeing the slides? You can program that space. No, typically you can't, Franklin, in terms of those solid state drives. You have some control over, but again, that's logical control. You can say, I can partition the drive, but there's actually some hardware layer stuff you don't have any control over. I usually do, by the way, I do that. If I buy a 200 gig solid state drive, I partition it into 2 100 gig drives, and I only use 100 gigs at a time. So you can actually artificially extend the life of a solid state drive by doing that. I don't know if it'll actually do it or not. I won't know for a couple more years. Anyway, the end user support function, again, that's usually handled by the failure control function. Some problems user encounter while using the network. Major sources of problems. Here are the major sources of problems. Hardware device failure. Those are generally the easiest to fix. The physical layer, believe it or not, is usually the easiest to fix because it's the easiest to diagnose. If your laptop is dropped and the screen is cracked, well, that's pretty easy to diagnose that. And it's easy to fix because you know how we fix most workstations these days? You throw it in the trash and give you another one. It's cheaper. I'm not going to repair your hard drive. I'm not going to repair your, your laptop. I'm not going to repair your cell phone. Your screen is cracked. It'd take me more time and more effort to repair your screen than if I just give you a whole other cell phone, which was built by a automated system anyway, not a human. Lack of user knowledge on proper operation, also easier to fix typically. How do we fix lack of user knowledge on proper operation? We either take that element away from them and try to automate more of the issue, or we train the user. We show the user PowerPoints, or we show them how not to have that problem. The first thing I was talking about, taking away the responsibility, that an example of that would be putting firewall or virus checking software on the workstation to make sure that the user doesn't get themselves in trouble because they might not be educated enough to know, hey, this is obviously a phishing software, a phishing email, P-H-I-S-H-I-N-G, and it's not real. Don't go to amazon.co.in because it's not the same thing as amazon.com. Not trying to pick on India, I'm just saying it's, an example of a phishing website. Looks like the real thing, but it ain't. Problems with software settings, or software incompatibility, that's usually the hardest to fix, and that's usually because it involves applications on 2 different sides from 2 different manufacturers. Or if it's an in-tiered technology where you're using a certain web browser, talking to a certain web server application that's then talking to a certain database server, which is then talking to a certain file server that has the actual physical data on it. Sometimes a breakdown occurs and all you as an end user see on the screen is some gobbledygook code, or we're sorry, we can't give you your data right now. So you call the help desk and you say, hey, I can't pull up my data. What's going on? There could be a lot of different things. Maybe you just lost your internet connection. So the problems that are occurring between the network nodes, between all those different layers of the tiering topology, or the tiering, that's not the right word, the hierarchy from client to server is more difficult to diagnose because we can't figure out where the breakdown is. We look at physical first. 99 times out of 100, the problem is either the physical layer, and then 1 times out of 100, or probably more often, it's the user, and then less often, but more of a problem, is when software breaks down or the process between multiple server hierarchy breaks down, the in-tier hierarchy breaks down. Training is an ongoing responsibility of the network manager. Training is one of the things that we are responsible for, but for most medium to large size organization, that training is one either outsourced or automated. Just like when you go to when you go to your new job, wherever that might be, hopefully at a good company and a well-established company, they're going to sit you down to PowerPoint videos or videos, training videos. Especially if you go to work for a manufacturing company, you're going to have to watch a certain amount of hours of OSHA training videos on how not to accidentally cut your arms off, or run over somebody with a forklift, or poison somebody with something. Even if you're a network manager, everybody that works in that kind of industry still has to go through the OSHA training, because there are sometimes the network manager does have to go down to the manufacturing floor and fix a network computer. Okay, cost management. The largest cost, and this might surprise a lot of you, cost management, the total cost of ownership, by the way, we have a term called TCO, total cost of ownership of one workstation in a year can be as high as $5,000 to $10,000 per year. Very expensive. Let's take a look at some of these items, the small items, the network devices. This is all of the switches and the routers and the cabling and all of the things that are interconnecting all of our client computers, which is another approximate 9%. The server computers, I guess, falls into network devices. So the hardware, according to this average pie chart here, is only 18% of your total budget. This is a yearly budget, okay? Application software, 8%. That's software that you're having to buy or rent. Maybe not buy, but rent. It's a service cost. In most cases, software as a service. Microsoft Office 365, for example. Network costs, the other costs here, this would be like the contracts that you have with the maintenance organizations, or the network providers. You have to pay Comcast or AT&T or Akamai or whoever you're using, or your GoDaddy, whoever you're using for your domains. You have to pay them X amount of dollars per year, which is, you have to pay it. You can't get out of it. 31% on average is end user support. That's the cost of the help desk right there. That's expensive. That might be in-house or that might be outsourced, but that includes all of the salaries of all the employees, all of the hardware and networking that they require just to provide the function of end user support. They have their own network and their own internal issues. All of the software needed to provide that end user support. And then look at the biggest chunk here. 38% is systems management. What is that?
Backups.
What's that?
Backups.
Nope.
People?
I mean, yeah,
People?
but it is people. Which people is it?
MIS people?
Me. It's you. It's the MIS managers. We get paid a lot. 38% of that budget is us, and all of the employees that work for us, and perhaps all the other people that we outsource to do systems management, which is not specifically end user support. it's interesting that this number is actually larger than the end user support on the average. That might not be true for some organizations. Some organizations, the end user support is going to be higher, and that depends on the organization and what they do. For example, if they are very user oriented, if it's a finance broker, for example, and they're handling money for people, moving money around is a relatively homogeneous, easy thing to do with networking, because you're selling and buying basically one thing, stocks or bonds. It's not like running a grocery store where you have 20,000 unique inventory items and 500,000 locations all over the earth. You know, with brokerages, you've got basically one centralized location, one centralized database, and you're only talking to maybe a dozen different data sources. You're talking to NASDAQ, New York Stock Exchange. So you do have more end user support in the finance and banking industry, but overall, it's the salaries and the cost of the network managers that are costing the most in the systems management. So in terms of saving money, if you wanted to take this budget and cut it down, because this yearly budget number that you're given is typically a single number. You're a single line item out of your company's not balance sheet, but income statement, your costs. Well, our total networking costs $5 million a year. Well, gee whiz, that's really high compared to our profit and compared to everything else. How do we get that down? Are you going to spend a lot of time trying to get better deals on application software? Are you going to spend a lot of time trying to get better deals on network devices or better deals on client computers? No, probably not. That's not your best bang for the buck. First of all, client computers and servers are much cheaper than they used to be, or don't exist anymore. A lot of organizations like University of Houston, for example, we don't have to provide nearly as many client computers as we used to, because you guys all have your own computers now. You all bring your own laptops to school, you bring your own cell phones. Back in the old days, we had to have labs with hundreds and hundreds of terminals in them so people could write papers or do whatever they needed to do, because it wasn't a common, normal thing, even for a college student, to have a computer at home. Not unless they were, upper middle class and had money to do that. So we don't spend that much money on that. Not much bang for the buck to get the best price. So the key here, guys, is whatever I'm doing as a human, whatever out of these two numbers, what does that add? That's 69. That's almost 70% of your budget. Automation. Automate as much of anything that you can with respect to systems management and end user support. In other words, the end user, help the end user do most of the stuff himself. Help the end user reset his own password. Put automated tools in place to train the end user. Watch PowerPoint presentations, watch videos, so that I don't have to have a class and pay a network manager $110 an hour to go talk to a room of new employees to say, okay, this is, you're working for this company. Make sure to change your password every 3 months. Don't do this, don't do that. Automation, that's the key. Cost reduction steps. Develop, okay, it's number 2 on this list, but in my opinion, that's number 1. Automate as much of the network management process as you can to save the money. Best bang for your buck, in other words. A lot of companies spend a lot of money up front to automate. As long as they made a good choice to automate, they save a lot of money, because typically they can amortize the cost of that automation for their next 10 to 15 years, especially if they're in manufacturing. Most of our cars that we drive, 90% of the car is built by robots, built by those big robotic arms. Okay, that saves them money because they're done the same way every time. They're boring jobs, but they cost a lot of money to get one robotic arm that can build a car, to weld a few things in one location. that might cost $250,000 or one of those. 5 times the yearly salaries that you might pay somebody to do that same job. But hopefully it'll last 10 to 15 to 20 years. Secondarily, develop standard hardware and software configurations for client computers, servers, and network devices. This is 2 parts to this. One, so that you can get better deals by buying in bulk, for example. You don't buy 5 of this and 10 of that and 20 of this. You buy 50 all of the same brand of laptop, even if it might be overkill for some of your end users, because you get a better deal on it. But that's really less of the reason. The primary reason is so that your help desk doesn't have to support a dozen different platforms. If I force all my employees to use a certain application, a certain Windows OS, for example, a certain brand of laptop, whenever they call, when they do have a problem and they call the help desk only has to worry about Windows 10, the 3 or 4 applications that you are supposed to be using, and you're all using HP Elite books or whatever. You're all using the same laptop. So the help desk guy can say, oh, okay, press that blue button in the upper left-hand corner, or we get very familiar with all of the little physical idiosyncrasies of the physical standard devices you're using. Because as we mentioned before, one of the most common things that happens is physical devices break down, or we as end users break them. Anything that moves is going to break, including people. We got to move around. We break down because we move around. Reduce the cost of installing new hardware and software by working with vendors. Yes, that's a thing, but again, it's not the biggest bang for the buck. Centralize or outsource your help desk. That's the same thing, centralizing and outsourcing it. We don't have a centralized help desk, or no, that's not true. We do have a centralized help desk at U of H, but the College of Business, we still do have our own help desk because we have some, well, we teach network management for one, but we also have some unique differences from the other colleges. But most of the other colleges, College of Education, the Music College, Hilton College, they rely on a centralized help desk for all of the failure control function and the end user support and the network operation support for the network. It's cheaper to centralize that rather than having individual little groups everywhere throughout a campus or an enterprise. And then finally, maybe not finally, these are just 5 of them, the best bang for the buck. Move to a thin client or cloud-based architecture, which also it could be outsourced. Not necessarily. Cloud-based might be you're renting space in a data center, but it's your servers, your OS, and your applications and your data. But what a lot of smaller companies are doing is they're like, you know what, we're not going to buy copies of Microsoft Office anymore because our biggest issue is Microsoft Office crashing or not working well, or we need to update it because of security issues. If we just pay X amount of dollars per month per user and let somebody else worry about where the data is physically housed and updating the code, software as a service, in other words, that's what I'm referring to. That is a thin client. If I remove all of the applications from the user and from the entity that uses those applications into the internet somewhere, it's kind of like the concept between owning a house and renting an apartment, although not quite, but it's similar to that. Anybody in here own a house, or do most of you rent an apartment? Pretend that you have a lot of money. And a lot of people that have a lot of money, they don't just automatically go out and buy a house, because owning a house is a big responsibility and there's a lot of systems that you have to deal with. If you don't have a lot of money, you a lot of times have to do it yourself because you can't hire plumbers and electricians and repairmen to fix things. You don't have the money to repair it, or you think you can repair it, or you think you have the expertise, but you are not an expert. Unless you're in the business of building houses, you're not an expert But that's a pretty major system. A house is a very major system. So a lot of people choose, and what we're finding, by the way, guys, millennials, which is a lot of you guys are choosing not to buy houses. You're renting. I'm renting. I don't own a house right now. I don't know if I ever will own another house again after all of the headaches I've had in owning houses over the years and all of the money. It's a big money game, in my opinion. Might cost me more money in the long run, but if, it gives me flexibility. If I decide, you know what, I don't like where I'm living anymore, I don't like this area, it's changed or whatever, I can I don't have to go through the hassle of selling a house. I can, wait till the end of my lease and move and get away. So that's the same kind of concept, flexibility. In the business industry, particularly now, we need flexibility. What's the number one cost for every organization? Number two cost is us, the network management. What's the number one cost? Of people. That's right, the salaries of people. That's where we have the most flexibility. So if people who are all of our users go away because we can't afford them or they need to go away, we downsize. If we spent millions of dollars on hardware and programs and contracts to support 1 million employees, and now we only have 100,000 employees, we can't cancel those contracts. We can't sell that hardware back. Maybe you can, but you're not going to make any money back on that. So a lot of organizations these days that are in a cyclical type of a business, such as the oil and gas industry. Oil and gas is very cyclical. For anybody that's in here that's in the oil and gas industry or considering it, realize that you're getting into an industry that you might be making $200,000 a year for 3 or 4 years, and then you'll be unemployed for 6 months. Then you'll be up here, then you'll go down. It's very cyclical. Even at the network management level, because if you're working for that industry, it doesn't really matter what you do. If they don't need you, if they can't afford you, they're going to get rid of you. So they like the flexibility. They like the fact that, you know what, we're not experts. Let the experts figure out how to write the code and save the data and restore it when we have problems. And that also gives those organizations, by the way, particularly publicly traded organizations, it gives them what's called plausible deniability to the stockholders. If there was a problem, they can say, oh, that was Microsoft's fault with their messed up update, for example. That's what caused our network breach. That's what Equifax is trying to do. They're trying to say, oh, that was Apache. That was Apache in their Ruby on Rails update, which had a security vulnerability. That was their fault. Well, again, that's that Apache is part of a open source distribution. I mentioned CentOS earlier. How are we doing on time? Oh, guys, you didn't tell me it's 4:14 already. We're way past the time. So let's finish up here. This was a lot, and hopefully this class helped you guys out a lot, because there are a lot of questions from chapter 12 on network management, and this is kind of the capstone of this class. Network management requires a technical understanding and management skills. That's why hopefully you were taking this class to learn and to dabble into some of the more technical areas. If you want to keep dabbling, I highly recommend that you sign up for my 4397 Open Systems class. There are multiple 4397s, so make sure you sign up for Open Systems, okay? OPENSYSTEMS. Managers must explain the business value of the network to justify its increasing cost. And networking, the cost of networking is one of the #1 increasing costs of most organizations, mostly because of the people. People used to be cheap. Computers were expensive. Now computers and programs and software is cheap. People are expensive. Where am I going to spend my money? Computers and automation. I'm going to hire robots. That's very true for a lot of organizations. That's why when you go to these different websites and you see these, hi, I'm Sally, these little pop-ups, that's all code. only when you start asking hard questions, like what's my balance on something, will then that automated user go, that's a complicated question. Let me pass you off to Joe here. And then it literally does contact a third party, which starts to answer your questions. But they're trying to be a first line of defense and handle the 80% of stupid questions a lot of customers have, a lot of end users have. Like, what are your hours of operations? And maybe those aren't stupid questions, they're just common, simple questions. Network management is increasing in complexity because networking is increasing in complexity and because everything's connected to everything else. Qualified personnel costs much more than the hardware. I mentioned that many, many times during the semester. So that's it for chapter 12. There are notes already. You should be able to see them. Let's just double check that real quick while I've got you captured here. There are notes let me log in real quick and double check that. I'll update the dates just to make you comfortable, and I might alter a little bit of the bullet points or add a couple of bullet points for the class. For exam 3, I'm checking out everybody's exam 2 to make sure that you didn't make any dumb, silly mistakes that counted off on the subnetting assignment part. So don't worry too much about that. If you go, oh my God, I left all the zeros out. Don't worry about that. It'll bump your grade up 2 or 3 points if that's what you left out. But let's see. This is. I'm just going to go to the 4477 link. But this also, I usually try to copy everything into 7387 as well, or 7397. Excuse me. Content. Exam 3 study notes. Let's click on that, see what it looks like. Oh, first of all, let's see. Do you have access to it? Can you guys all see the study notes? It doesn't say they're not available, so you should be able to see them. It's going to be, it says 30 to 35 to 40. I'm actually going to pare that down to 30 multiple guess questions. Okay, so there won't be as many. The questions will be worth more, so read them carefully, but there won't be as many. It says there's fill in the blank. There are fill in the blank. I don't recall fill in the blank. There might be some very short fill in the blank. I have to take a look at this version of the test. I had told you before there's not going to be any long essay style questions, and there won't be. So if there are fill in the blank, it's going to be a very simple fill in the blank kind of situation. Okay, so I may take those off, but I might leave those on. I need to look at the exam and see what those fill in the blanks were. My promise still is that exam 3 will not be as hard as exam 1 and 2. Questions are pulled from chapters 10 through 12. Same rules apply. You take the test, but it's open book and open note and open internet. Use Google, use Wikipedia, use whatis.com. Use my notes. It should grade the test immediately. If the fill in the blank is either right or wrong kind of situations, I need to look at it. It should grade the test immediately. If there is a curve, that'll come in a couple of days after you take the test. I'm going to give you until Friday at midnight. Excuse me, back up. Saturday at midnight to take the test. Okay, this Saturday, July, what is that? 2nd? No. Hang on, let me double check. July 4th. So this Saturday is July 4th, Saturday night. Nobody's going to be doing anything July 4th because of COVID-19. So stay indoors, take the test. Well, it's probably safer anyway because there's crazy people out there shooting fireworks at each other. If you have any technical issues, we still have another day to deal with it, or another 2 days actually. I have to get the grades in by Monday. So if Sunday morning rolls around and you had some tech issues, send me an email and say, my internet went down, fireworks were going off all night and I couldn't concentrate, whatever it was. send me an email. I'll take it on a case-by-case basis and figure out if I need to do anything else for you. Keep working on your homework assignments. I suggest, if you're not making a good grade so far, and it probably will go up. It'll probably go. Don't look at the overall grade, by the way, right now. That's not going to be accurate. What you need to be looking at is your score on exam 1, the homework assignments you were supposed to have done with grades, and your score on exam 2. Use those to calculate what you think your grade's going to be. The exams, of course, are the majority of the grade. Because we didn't do the network game, because we didn't do the cable making, the exams are going to be worth more like 30% each. Okay, 25 to 30%. So go pay attention to those. Don't go by that overall grade number that you see in Blackboard, because it's misleading. It doesn't calculate properly until all the grades are in. So what I was going to say is, strongly encourage you to do the Wireshark assignment as best as you can do it. Okay. Franklin sounds like he was trying it. We were having some issues, but even if you do have some issues, at least try to accomplish it. Show me something. I'll give you some credit for it. You're not going to get 20 points for it like the original 20%, but you'll get a few points for it on top of your grade. Okay. So if there's no more questions, I appreciate everybody hanging out this semester. The win, SCP helped a lot. Good. I'm glad. So yeah, again, in a perfect world, you're in that lab with access to multiple machines. Makes it easier, but a lot of you have one laptop at home. So it's not as real world of an example running Wireshark. Because if you go to 127.0.0.1, your Wireshark's probably not even going to show that. It's looking at stuff that's going in and out of your network port, your Ethernet interface at layer 2. If your computer sends something, one application sends something to layer 3 in your computer, and it's for your computer, it's going to go right back up to the other application. It's never going to get down here to layer 2. So you won't see it in Wireshark. So if you are going to use Wireshark to look for it, you either have to choose loopback interface on that first interface screen, or you have to send it to the IP address of your computer, 192.168, whatever it is, not the local loopback, or you probably won't see it in Wireshark. Keep emailing me, letting me know where you're at, where you're stuck, and I'll be answering emails pretty much from now until Saturday night, trying to get you guys pushed along. And again, thanks a lot for bearing with me this semester. And hopefully I'll see some of you next semester in the fall if you sign up for 4397.
Professor, I want to speak one-on-one with you.
What's that?
I want to speak one-on-one with you. Do you have a few minutes right now?
Yeah, you want to talk to me one-on-one?
Yes.
You want to just call? You want me to call you on the phone?
Yes.
Okay. Why don't you send me a private message in Zoom? Well, I tell you what. Send me an email. I want to end the Zoom meeting now so that I can save it and upload it to YouTube. Send me an email, jake@uh.edu, and I'll give you a call. Okay. That's holds true for anybody else as well. Okay. If anybody else wants me to give them a call now.
Mom and WhatsApp audio.
What's that? Oh, was that an application?
Okay. I will send you. I will call you or text you my contact.
That's fine. You can also text me at that 409-331-5253.
Okay. Thank you.
I'll give you a call back. All right. Oh, here we are. All right. Thanks for a challenging semester. Go Cougs.